Hi there, we're continuing section 3.1 on the functions of several variables. We're starting in on subsection 3.1.4 on the graphical representations of functions. And how a function is represented graphically depends greatly on how many input variables that function has. The usual or canonical representation of a graph of a function z is equal to f of xy is as a graph in three-dimensional space, where the z value represents the height of the function surface, either above or below the x, y plane. So for example, if we go and sketch a surface that passes the vertical line test, so that represents a function graph. Give a little bit of shading here just in blue. The idea is that for any point down in the xy plane, then the z value represents the height of that surface, either above or below the xy plane. So the coordinates of that point is x, y, and z, which is calculated as a function of x and y. Now I did my shading in blue, but sometimes, however, you're going to see different colors being added, and these are things that are called color maps. And typically colors, when they're added multicolored to the shading of a graph, they are in the order of the rainbow, with larger z values being shaded red and smaller z values being shaded blue or violet or purple. So let's go and do a graph with some color shading. Let's draw a paraboloid, maybe a downward facing paraboloid centered at the origin. So if I were going to shade this multicolor, I would use red for the highest value, and I would go down the surface in order of the colors of the rainbow to add an extra visual cue as to the height of the function surface in each of those places. Now this is a three-dimensional graph, and very often you'll see a three-dimensional function graph represented in a two-dimensional way, and that is with these colors projected down onto the xy plane. So the idea is all of these rings that are on the function surface get projected down into the xy plane. So if we go and do that here, that's not good. Better. We would get rings in the xy plane that represents the rings that are up on the function surface. So by looking at the colors, you can get an idea of how high a function graph would be. Now what's the point of that, you might ask? If we have a z-axis sticking right here that we don't use, well, there's not really any point. Instead, we would transfer these into a standard xy plane and draw the projections down flat. And this kind of graph you may think you're seeing for the first time, but I bet there's actually something that you've seen before which uses this that you didn't really think about. And as soon as we get the last little shading in here, we'll take a look and see at what that is. So the idea of a graph like this, a flat two-dimensional graph representing a surface here, is that you've drawn this completely flat. You don't have to do any perspective drawing. You can imagine this red value being coming out of the page at you like it is up here, and the rings of increasing color going up in the surface. So it lets us represent a three-dimensional surface in a two-dimensional way. This kind of graph is called, well, let's show you the picture. The kind of surface is called, or the kind of graph is called a color map or color plot, or sometimes a temperature map or plot. And the reason that it's called that is from the kind of image that you've probably seen before. You take one look at this, and nobody has to explain to you. You know exactly what's happening. And the higher temperatures are where the graph is red. The lower temperatures are where it's purple. You can see that the temperatures are decreasing this way. That's exactly the same concept. If we added a set of axes here, which would be kind of funny thinking of the world on a set of axes like this, but if we did that, we would have a perfect color plot. So the exact same thing now, we would imagine a surface. So the surface would have low spots here and higher spots here, and would be increasing in this direction. And that kind of temperature map is something that you have seen before, I am 100% certain. So in the next video, we'll look at some other ways of representing three-dimensional graphs in two-dimensional ways.